Children, till last week we have studied that derivative using first principle, that is limit h tends to 0 or x tends to 0 x plus h to the power n minus that formula. Now in place of that first principle formula, we are going to do differentiation using the direct formula. Now how to differentiate it? As we are knowing that from a second chapter we are studying a function. So function, how we are denoting, that is y is equals to f of x, that is a function. So if I will write f of x or y, meaning is same. So here f of x is this. So suppose I am having f of x is equals to general form x to the power n. Now many formulas will come, and these all formulas you have to remember. Without formula you can never complete this derivative. It is just in 11th standard initial of calculus. Now if this part not understood to you in 11th standard, so it is going to be very much difficult in 12th standard. Again I am repeating, here you have to remember in a calculus many formulas, and there is no option. Anyhow you have to remember it. Now see, first of all, suppose your function is of the form f of x is equals to x to the power n. So if I want to find out its derivative, so that we can denote it as f dash of x, which is equals to this power will come forward and x to the power n minus 1. We have to subtract 1 from the power. So this is a formula. If you will apply this formula, directly differentiate it. Now in place of this, we may write down y is equals to f of x. So in place of this, see, here our function is in term of x. So we have to differentiate it with respect to x. So in place of f dash x, we can write down dy by dx also. So we can write dy by dx is equals to n x to the power n minus 1. That is also seen. In place of dy by dx, we may write down y1 also. We may write down y dash also. So that these are the different ways to represent a derivative, but ultimately the meaning is same. So here in place of applying that a direct function, here I will apply a direct formula. So here a function given f of x, and we have to find f dash, or we have to prove that here f dash of 1 is equals to 100 times f dash of 0. It means 1 is the value of a variable. So first of all we will find out, dash means what? Derivative. So first of all we will find out its a derivative. So f dash of x is equals to, here observe children, my formula is x to the power n. If I want to find out its a derivative, so I can put into this form, d by dx of x to the power n. So it will be n x to the power n minus 1. This formula here we are applying. So f dash of x is equals to, observe, x to the power n form. So power will come forward 100, x to the power 100 minus 1. Observe, n minus 1. 100 minus 1, so here 99 will come upon 100 already were there in the denominator. Now similarly, the same formula again will apply. Power will come forward into x to the power. From a power we have to subtract 1. So 99 minus 1 will get 98 upon 99. This 99 is not of the formula, it is already given in a question. Up to x square. So 2x, 2 minus 1, that is 1 only, upon 2. Now see, derivative of x, so x power is 1. So 1x to the power 1 minus 1. So 1x to the power 0. And a number having a power 0, it is going to be 1. So here 1 will come, and derivative of constant is 0. Now here observe, 100 cancel, 99 cancel, 2 cancel. So we have x to the power 99 plus x to the power 98 plus up to x plus 1. Now we have to find out, children, f dash of 1. So here let me consider this one as equation number 1. Here f dash of x. So putting x is equals to 1 in equation 1. So f dash of 1, in place of x, everywhere we have to substitute 1 only. So 1 to the power 99 plus 1 to the power 98 plus up to 1 plus 1. So now children, you may observe 1 to the power 99 will be 1 only. 1 to the power 98 will be again a 1, up to 1 plus 1. Now you will observe 99, 98 till preceding term 1. It means these are 99 times 1 and 1 extra 1, that is 100 times. So here I can write it is, this part is 100 times. So 1 you will add 100 times, so you will get obviously 100. So that is your f dash of 1. Right, this is your equation number 2. Now what we want? F dash of 0. So putting x is equals to 0 in equation 1, putting x equals to 0 in equation 1, we get f dash of 0 which is equals to c. 0 to the power 99 is going to be 0. 0 to the power 98, again a 0 plus 0. So these all quantities are going to be 0. Only this one will be left out, so which is equals to 1. That this is your equation number 3. Now this equation 2 we can write down from, observe, from 2 and 3. What we can write down? We have f dash of 1 which is equals to 100. May I write down 100 equals to 100 into 1? Because 100 ones are 100 only, as we are knowing, and in place of 1 I can write down f dash of 0. So f dash of 1 is equals to 100 into f dash of 0. Hence proved. So children, hope this proof